Hello, my Algebra 2 students. It's day 4 of Unit 8. We got multiple things to talk about, so let's get going. First thing says determine the equation of the cubic function with roots -4, 2, and 5, and it passes through the point 620. This is the same as example 3 from yesterday. So if you flip back in your notes, and I happen to have mine here, that is this guy right here. So the answer in factored form, well, the easy part would be the x plus 4 and the x minus 2 and the x minus 5. But then we had to use this last point to solve for a. So it came out to be 1/2. So that's the answer in factored form. Then in standard form, just as a reminder, we took all of this and we multiplied it all out. Our notes. So 1/2 x cubed minus 3/2 x squared minus 9x plus 20. So that's what it looks like in standard form, because this means ax cubed plus bx squared plus cx plus d. That's what I'm talking about when I say standard form versus factored form. All right, now it says use a cubic regression to check your answer. We haven't done this yet, but we've done regressions. So to be able to do this, you have to have these values in your lists. So what I want you to be able to do is in your list, so you're going to go to Stat, and then Edit, and then in L1, you're going to put all the X values, and then in L2, you're going to put the Y values. So what I mean by that, since your roots are x-intercepts where the y values are 0, you'd have -4, 0, 2, 0, and 5, 0. And then we have that one extra point, that's 620. So into your calculator is what I want you to do right now. All right, so if I go, make sure you can see this, go to Stat, and then Edit. I'm going to put mine in list 3 and 4, but you can put them in list 1 and 2. So you're going to go -4, 2, 5, and 6. And then in the list next to it, 0, 0, 0, and 20. So those are the corresponding y values. Then what we're going to go and do on our calculator is a cubic regression. So we're going to do Stat, and then Calculate, and then Cubic Regression. So Stat, go over to Calculate, choice 6 is the cubic regression. Now, because I put mine in list 3 and list 4, I'm going to quick switch them, but yours should be good to go if you have them in list 1 and list 2. And then just hit enter. And now take a look at what you get. We get a equals 0.5, so 0.5 x cubed. B is -1.5 x squared. C is -9, so then x, and then plus 20, which perfectly checks against what we did by hand in class yesterday. Now, if you think about it, that's an awful lot faster to let the calculator do the cubic regression. So you can always multiply it out yourself, or you can let the calculator do the work. Now, if it was that easy, I would have shown you that day 1. When it says, can we use a regression to find the answer for every polynomial function when given the roots? The answer, sadly, is no, and here's why. So the next example is example 4 from yesterday's notes. And it says, determine the equation of the cubic function that has a double 0 at -2 and another 0 at 4. So if we take a look, let me grab that sheet from yesterday's notes. When it says write the equation in factored form, we ended up with this. So let's copy that down. So in factored form, we ended up with -1 times x plus 2 squared, and then times x minus 4. All right, in standard form, let's multiply this guy out because we had not done that in the notes themselves. So we would end up with x plus 2 squared. Let's do that. That's going to give me x squared plus 4x plus 4. If I then multiply that by the last binomial factor of x minus 4, here's x cubed plus 4x squared plus 4x minus 4x squared minus 16x, and then minus 16. All right, so I would get -1 times all of this, x cubed, plus, oh, looks like that part actually cancels right on out. That'll give us minus 12x and then minus 16. So now when we multiply it all out, this will just switch the signs. Lovely. All right. When it says now use a cubic regression to check the answer, we could try, but what I'm going to tell you is it's not going to work. So what I mean by that is if I go to my list 1 and list 2 and tell it the values that I would know, the fact that I have a double zero at -2 means I would technically say, okay, those are 2 roots there at -2, 0. We'd have 4, 0, and then we'd have that extra value or extra point at 0, 16. If I go into stat, edit, and I'm going to fix my list 3 and list 4. You can make yours list 1 and list 2. And if I go -2, -2, 4, and 16, and then over here, it would be 0, 0, 0, and then 16. Oops. Okay. If I now go to stat, calculate, and run a cubic regression, it's going to give me error. When you have a double root, like you have right there, the calculator will not do the regression. Let's say the calculator cannot run the regression. Let's say it that way. So even though it's an amazing shortcut, and I highly suggest you use it for questions like up top, if it turns out that you're trying to write it in standard form and you have a double root, you are going to have to do the work yourself. Flip on over here. It says the owner, of Dizzy Lizzie's, an amusement park, are studying the wait times of their most popular roller coaster. So the table below shows the number of people standing in line for a roller coaster T hours after the park opens. So the number of hours after it opens, that's typically like your X for time. And then your Y value, that's the number of people that are in line. So that is what I already had in my calculator in my L1 and L2. So I need you guys to get that in your calculator. So go to stat and then edit. And we're going to put this into list 1 and put that into list 2. All right, so once you have everything in the list, we're going to turn on the stat plot. So when you go to your Y equals, you want to see that plot 1 is highlighted. Your other option is to go to second Y equals, and you can check to make sure it's on, or you can turn it on there. Once you do that, we're going to go to zoom, and then 9 is zoom stat. So zoom 9 is going to pick a window so you can see those points we just put in the calculator, and now it's plotted for us. So when you look at it, it says, do you agree that a cubic polynomial function is a good model for the data? What else could have been used? So I can imagine that a cubic function would go through this, but it sort of looks like a quadratic, like a parabola shape. So I would say yes, sure, right? But a parabola would have been fine. Like an x squared, maybe. When it says, what is a reasonable domain for the function? All right, well, domain, take a look at the values we used. We went from 0 to 12, so that would be the domain that I would look at here. Right? Then it says, use the graph shown, estimate the time at which the line is the longest. All right, so they've graphed it for us. We'll do it ourselves in a moment, but for now, looking at this, when it says estimate the time at which the line is the longest, we're looking at the highest point on the graph. So if we look all the way up here, what time is that happening at? Well, that's the X value. So I want the X, or I should say the T value. So if I go over, that looks at like 5, 6-ish, maybe 5.5, something like that, hours, somewhere in that range, right? And then it says about how many people are in the line at that time. Well, what's that maximum value? So it doesn't go up to 375, so maybe a little bit below that, maybe like 370-ish. And I shouldn't put question mark. Let's just say approximately. we'll go with more confidence here. All right, now it says use your calculator and determine the cubic regression that would model the data. Since we have everything in the calculator already, we're going to go to Stat, Calculate, and then come down to Cubic Regression. So it's in list 1 and list 2 for me, hopefully for you too, and then run it. All right, you can see the more data points, the messier this is going to get. It says to the nearest hundredth, so to 2 decimal places, let's record this. So it should be 0.37 x squared, x cubed, minus 16.61 x squared, plus 150.30x, minus 21.25. Now I wrote x's and y's. Technically, this is p, and then this is t, and so on. All right. Either is fine. It's not a big deal. Now it says use the equation that we created, so the one our calculator just gave us, and determine the time at which the line is the longest. All right. To do that, because it's cubic, it's not like a negative b over 2a. It's not quite the same thing. So let's type it into the calculator. Let's go 0.37 x cubed, and then minus 16.61 x squared, plus 150.30 x, and then minus 21.25. All right, just hit graph because your window's already set. And now to calculate that top or that maximum point, you guys know this, you are well trained. Up here, if I want that maximum, second, trace, max. Let's let the calculator do some work here. So second, trace, max, shift to the left side of it, hit enter, shift back to the right side, and then take a guess somewhere in the middle. All right, where I'm landing at is that my x or my t value is at like 5.55, keeps going, and then my y or my p value is 364.5 and change. All right, so when it says determine the time at which the line was longest, yeah, about 5.6 hours. So we were pretty set on that. And then the most number of people is about, it's a person, so let's round to a whole number, 365, people. We said about 370. That's pretty darn close right there. All right. So when it says how accurate, I'm going to say we did pretty good. We were pretty accurate here. All right, now it says use the equation, determine the number of people in line after 8 hours. All right, 8 hours is a t value, or x, however you want to think of it. So you have some ways that you can do this. You can plug it right on in on the home screen. You could go to, let's maybe use the table of values, and let's go look at x here. So I can go to my table and come over to x equals 8, and we get 307.55. And so I would say that that's about 308 people. Then it says, does it match the data you were given? Why or why not? Well, go way back up to the top. Up here at 8 hours, it says there's 310 people in line. We figured out that at the 8-hour mark, there's 308 people in line. So when it says, does it match? Well, technically no, right? Because it's supposed to be 310 people. Is it really close? Absolutely. But when it's saying, why does this happen? Well, we rounded our answers. The second we round our answers, it throws off, or rounded like these decimals, it's going to throw off our values a little bit, right? So since we rounded, the coefficients, the answers are slightly off. They're still pretty good. They're still pretty reliable, but they're going to be a little bit off there. All right. This last little page, I actually think might be nice to talk about this one in class together tomorrow. So let's stop right there. Thank you guys so much for watching, and be prepared to do some work together tomorrow in class.